We are going to solve exam type problem number 2. First, we go to the description of this. It says here, in a government process, a person spends an average waiting time of 2 hours before having his information revised. Let's assume that the process or the facility is closed, so we have to wait these 2 hours before they open. This information revision takes 10 minutes. Later, we will try to get attended by one of 4 executives. If it's not possible, we leave. If we get attended, the time of this operation is 30 minutes with an exponential distribution. Subsequently, we pay in cash, where 70% of us pay 1,500 pesos, and the remaining pays 5,000 pesos. We are going to simulate this for 100 persons, and we are going to answer 3 questions. How much time does it take a person to leave the system attended? How much time did the government, how much money did the government lose? Change this time to money. And modifying the problem to work in just in time. Okay? As in other videos, we're going to see the diagram to give an explanation of this problem. First, there is an a constant arrival of 2 minutes per client. We are going to wait 2 hours, 120 minutes. We don't need a queue to wait. We don't need to wait. But when, because the facility is closed, so when the facility is open, the government facility is open, we form a line, we form a queue, and we wait for a revision process of 10 minutes, but we wait in a line. Then we see if one of 4 cashiers are available. If they are not available, we go. And if they are, we go to them, we get attended in a time of 30 minutes and standard deviation being exponential. And then we go to pay and we form another line. And at the time of payment is when 70% of the people pays one kind of payment and 30% of the people pays another kind. The description of the problem didn't say this, but we are going to consider that the payment number 1 takes 3 minutes and the payment number 2 takes 5 minutes. And they pay 1,500 in payment 1 and 5,000 pesos in payment 2. This is needed to calculate how much money did the government lose. And we end the process. We need 100 persons to end this way, not this way. So when we use this terminate in the program, we are not using terminate 1 for this exit. We are using just terminate 1 for this exit. So the start in the program only counts the people who ends the process and not the people who exit the process before being attended. So let's go right now to the solution. This time I'm going to explain it here in the PowerPoint slide. We have the definition of an exponential distribution, the definition of a normal distribution. We have one storage being cajeros, and that's the only definition that we need. We really don't need the normal distribution, but I kept it either way. We generate we generate transactions every 2 minutes. We advance 120 minutes. This is the first things we need to do. Then after waiting these 2 hours, the facility opens, and then we start a queue of I called it fila 1. Then we cease revision, we depart fila 1, and then we advance for 10 minutes. This is the 10 minutes of this process right here. Then we release this revision and we transfer both to a line called intento, and if not, we go to salir. This in the process is this part right here. We got the revision, so we are not going to see if the cashiers are available. If they are available, I'm going in this part of the program, and if not, this is salir and it's terminate without a 1 because I don't want the start to count these people. So in intento, we enter cajeros, we advance 30 minutes with an exponential distribution, we leave them, we depart, we enter a queue called fila 2. This is this queue, we are in line to pay. So we queue fila 2, we cease pago, and then we transfer 0.7 to pago 1 and 0.3 to pago 2. The transfer is just before the advance to pay. It's right here. We are in the same line. There are not two different people attending us. It's just one person, one cashier in this part. In this part of the problem is one cashier, but the payment is different, and the payment takes, if it's payment 1, it takes 3 minutes. If it's payment 2, it takes 5 minutes. So we need a transfer just before the advance, and this is this part of the program. So in pago 1, we advance 3 minutes, we release pago, and we terminate. In pago 2, we advance 5 minutes, we release pago, and we terminate. And this is the program. How much does it take a person to leave the process attended? First, we need to define an equation that represents this time. In this problem, we need to start thinking about how to answer the questions. They're not just to go and read to the results of the program and read a quantity right there and answer the question. In this time, we need to think a little bit more about this. And as it says here, we need the diagram. If we see how much time do we need to wait, we need an equation that it's represented right here. First of all, we wait 120 minutes. This is this part of the program. Then we wait in line in this queue. We need to know the waiting time of this queue. Then there is 10 minutes of time with the revision process. 30 more minutes of the cashiers. There is no line in here, so there is no waiting. Then we wait in another line. This is waiting line for queue number 2. And then we part our time. 70% takes 3 minutes to be attended, and 30% takes 5 minutes to be attended. And this is the equation for this. We run the program, we see the results, we see the average time, and we establish that the waiting time in this problem is 1,208 minutes, 513. The second question, how much money did the government lose? We need to define another equation for this money. And this is a simple one. We just see this part of the process. 70% goes to pago 1, 30% to payment number 2, and we are using the money part of the program. We know that it's 70% times 1,500 times the lost clients, and 0.3 times 5,000 times the lost clients. What lost clients? The ones that went away in this part of the program. We need to establish this. And for this, we just need to read the results and see how many lost clients did we have. We go, the line was called salir, so how many terminate? 14. So we substitute this 14 in lost clients, and we have that we lose 35,700 pesos a day. 35,700 pesos a day. So this is a lot of money. If we times this 25, that are the days that the government works in a month. So it's a lot of money. We can get another cashier. We can do a lot of things to improve and get this amount of money. And how do we do the just-in-time part? For the just-in-time, this is the easy. We need the waiting times to be 0. We need the waiting times in the queues, in the lines, to be 0. How can we achieve this? By synchronizing the frequency of the arrival times of attention, by making every advance in the problem equally to the arrival time. So if we go back to the diagram, we must eliminate these 2 hours of waiting. The clients are going to keep arriving at 2 minutes. The revision must take 2 minutes. The cashiers can take more than 2 minutes because they are 4, but maybe I don't need 4. I'm just needing 1 and taking 2 minutes to perform his process. And also in the pavements, we can take 2 more minutes. So we synchronize the arrival and the process, and that's lead us to just in time. But as we said in the last problem, in exam type problem 1, we need to work on that changes in order to change those times in the simulation process. So this is it for exam type problem number